Hello. Good morning. This talk is called Are We There Yet? Remix. I'm going to explain the title in a second. Just a little bit about me. I was an early adopter of React. I think that's how I kind of got involved in ReactiveConf, is because I think in 2013 I talked about why I thought it was cool. Some of you that were around, that have been using it that long might remember. But since then, I've been doing a lot of professional closure development. I'm currently a software engineer at this company called Vouch.io, where we're kind of rethinking security and cryptography. But that part's interesting, but it's only 5 developers at Vouch.io. It's a kind of a startup. But our entire stack is functional programming. We use Clojure and ClojureScript for everything. Clojures for all our backend services. We use ClojureScript plus React Native to build our mobile client. And we also do this neat thing where we have an SDK version of our code base where we need to deploy that for both Java consumers as well as Objective-C Swift consumers. And we only write that code once in ClojureScript. And we ship ClojureScript inside of a wrapper which exposes the idiomatic APIs for whoever is consuming that particular version of the SDK, which is pretty cool. So we're able to be very productive with a very small team, very agile, which is interesting. I'm not going to talk that. Oh, one other thing about Vouch.io that's pretty cool is we use this thing called Datomic Cloud, which is a product from this company called Cognitech, where I used to work. So I don't work at Cognitech anymore. It was great, but I work at Vouch.io now. But we're using Cognitech's Datomic Cloud, and that actually is an interesting piece of technology if you're interested in Clojure and ClojureScript, because it's basically Redux in the cloud, right? So if you like Redux and functional programming and having control over your state, imagine if you had that level of control over your entire database. Datomic Cloud is effectively a gigantic immutable JS map in the cloud. We can time travel over our entire business domain, and that's pretty crazy and pretty cool. So if you have questions about that, I'm not going to talk about much more about that today. Feel free to ask me questions after the talk, and I believe I'm going to be on the discovery stage today at like 5:30. So if you have questions, come find me. I'm going to talk a bit about Clojure and ClojureScript, but this is not like a pitch, right? I'm not trying to convince anybody to use Clojure or ClojureScript. Clojure and ClojureScript are great bits of technology. I would say we have a modest community. It's sustainable. I think that's the most important thing about a programming language. You have a sustainable community. Clojure is now 12 years old, and ClojureScript is about to be 9. It's 8.5 months. I've been the lead developer of ClojureScript since 2011, so I've been there since the beginning. Again, they're great technologies, but the point about this talk is you're probably doing ES6 or you're doing TypeScript. Maybe some of you are doing Flow, but based off the surveys, I'm really most of you are doing JavaScript and TypeScript. It's to think about what are the semantics that TypeScript and JavaScript give you, where are they going, and what is it that these other interesting languages like Elm, like PureScript, like ClojureScript that target the same platform, right? The benefit of something like JavaScript being ubiquitous, kind of like what I said we're doing at Vouch.io, is that we're able to completely leverage the fact that JavaScript is everywhere. We can target Node, we can target phones, and there's a lot of power here. And I think that now more than ever, because I think things are changing with how quickly JavaScript or TypeScript can evolve, it's a good time and it's very low risk to say, well, I'm already on the JavaScript platform. Let me play around with some of these different languages and see if they provide new tools for solving problems. I mean, that's really why one chooses a programming language. A programming language may or may not let you write better software, but it will definitely show you new ways to solve problems. Hopefully, your whole team can understand that, and that will allow you to ship better software faster. You can't do it by yourself. I mean, it requires effort. Programming is, in the end, a social activity. So the name of this talk is a riff on this talk by Rich Hickey that he gave 10 years ago. Yes, 10 years ago. Just a little more than 10 years ago at the JVM Languages Summit, which is a yearly summit for both language designers and JVM implementers, people who implement the virtual machines, to come together and talk about what are the challenges for implementing languages which are not Java on top of the JVM. The JVM has a published bytecode. And so you're able to target that technology. But of course, there are things that the JVM could do to make the job easier or harder for language devs. So when he gave this talk, he was pointing out that in 2008, I mean, Java, and nothing has changed in 10 years, and we're going to come back to that, that mainstream OO has really succeeded. And this is not a bad thing, right? Mainstream OO, people learn it in school. It's effective. There's a lot of literature on how to write good software using OO techniques. And Java and C# to me are kind of like the high water mark of what's possible. Like, there's not much in that space that's happened significantly, right? Those technologies are good, and there's some sort of minor activity around making things a little bit cleaner. But I would say in 10 years, not that much has changed. And in fact, when Rich Hickey had given this talk in 2008, not much had changed since really JDK 1.5 or the versions of C# that were floating around. And in this talk, he talks about, well, what if we did things differently? What about functional programming? What about immutable data structures? So if you're familiar with Immutable.js from Facebook, something that came out in 2014, those data structures are actually ones that Rich Hickey designed himself, and he did that work in 2004, right? So there was a 10-year gap from when Rich Hickey innovated using some existing literature, but did a lot of innovative work, that 10 years later that appears as Immutable.js. So again, this is all pretty old stuff, but you really could give that talk again today, and that's why I'm sort of giving this talk, and why it's called Are We There Yet Remix. I follow the JavaScript community. I don't do much JavaScript, but of course I have to follow it. I maintain a compiled JavaScript language. I have to know what's best practice because users of ClojureScript want to be able to leverage the ecosystem. They want to use the same tools. They want to be able to access all these libraries that are great, that you all have access to. And perhaps in a simpler way because the tooling is already set up. In ClojureScript, for us, because we use things like the Google Closure compiler, there's a bit of more work for us to do. But we also want it to be easy because we believe there's tons of value in the ecosystem. But so I follow things in the JavaScript community, and this last survey to me was very surprising because you see this massive ES6 adoption, which of course I think it's clear, right? For me personally, I've been doing JavaScript since 2005. So I remember back in the days when the only clue you had was when IE6 would crash. Right? When it crashed, and then you could start putting like try catches or until the point where like, okay, it hasn't crashed yet. So I remember the dark days of JavaScript. So things have, of course, improved a lot. Specifically with ES6, personally, I'm extremely happy that they added modules as well as async await. Those two, for me, removed so much incidental complexity. I mean, 10 years of JavaScript, there was no standard way to load some other bit of code. I mean, that ruined the ability to do serious library development. It ruined the ability to have a very sophisticated dependency chain, like you have a lot of components you want to pull in. And just solving that was huge. And then, of course, all JavaScript, all meaningful JavaScript that you're going to write is going to involve asynchrony. And that was never fun. And I believe async await reduces the sort of incidental sort of complexity around, okay, what does that code look like? Is it readable? And how can I do the error handling in a sensible way? And I think async await covers just the most basic activities there. So it's not surprising to me that ES6 plus async await is seeing rapid adoption. But the surprise for me was TypeScript. In this is last year that more than half the survey of people that took the survey had used TypeScript, right? Almost half, 46%, not half, not quite half, but almost half. And that's very interesting to me. And one thing that was hard to figure out from this survey was that is that because you have JavaScript people who like ES6 and they're interested in typing ES6, or is it also the fact that you have a massive demographic of Java and C# programmers that are like, TypeScript lets me do Java and C#, which it does, right? It has all of the typing features one would expect. Generics, a very sophisticated form of generics. They've done a ton of work to be able to type relatively sophisticated functional patterns. So there's very good coverage on JavaScript semantics, but it lets you, if you wanted to, you could do full-on factory style Java programming or C# programming. TypeScript enables that. So my question is that number based off an influx of people who are like, finally, enterprise programming in JavaScript? And again, I'm not saying that's a good or bad thing, but it's interesting because what does it mean for the evolution of JavaScript and how we use it and how we think about it? Is the end game for JavaScript that JavaScript is basically a slightly more expressive, Java or C#? Is that really the high watermark for this language? One interesting property of TypeScript, and TypeScript is a very cool bit of technology, is that the thing that I like about TypeScript is that it has this thing called interface. So you don't have to make a class. So the interface allows you to decouple the shape of the thing you want to talk about from having to make any class for that thing. And that's actually really big. It means, you could say, oh, that lets me take an existing untyped program and make a type, and that's one way to think about it. Another way to think about it is it lets you stay sort of data-oriented. You can focus on writing a data-oriented functional sort of program, and TypeScript allows you to express specifications about that without having to write a bunch of class-oriented boilerplate, right? You can just write an object literal that has the properties you want. You can write the TypeScript interface for that, and you're going to get a nice specification, a nice compile time error. And I think that's really, really nice. And I'm curious, again, I don't use TypeScript, and the survey doesn't drill into this dimension. Is that something that people are going to really embrace? That TypeScript really does, because of that feature interface, it lets you think about constructing your type-checked programs very differently if you were open to this idea than you would be if you were just had your Java or C# classes on. But in the end, even if you do that way, and I think that is interesting. That would be an interesting way to think about typed JavaScript programs. The question remains, what's really next, right? Once JavaScript got async await and once JavaScript got modules, it becomes harder and harder. And now that TypeScript is available and you can have comprehensive typing of all interesting major JavaScript idioms, what's really next for JavaScript as a programming language that's significant, that's not about like platform stuff? WASM, of course, there's a ton of work to do there. Concurrency, there's a ton of work to do there. And possibly things like, okay, we want long or enhanced numerics, because again, that actually is more about platform stuff. But purely from the standpoint of features that the language provides that help you solve problems differently, what more can JavaScript really provide? And I would actually argue, given how long it took to even get to async await as well as modules, because there's so many stakeholders. Google, Apple, Mozilla, and Microsoft, they all have to be okay with anything that gets proposed to TC39. Any of those people vetoes it, and it's unlikely to happen because they implement the VMs. So my looking into the crystal ball is that actually I suspect innovation for JavaScript as a language is probably going to slow down to a snail's pace. You'll probably see some syntactic sugar. You may see some minor additions. But I don't see that much happening. And this is the moment where I think you can say, look at the existing ecosystem of JavaScript as a platform and say, okay, we love the ecosystem, we love the platform, the technology, but maybe it's time for us to be like, we can do all the stuff we were doing, but maybe we should assess Helm, PureScript, ClojureScript, because those give us new tools, new insights on how to write simpler programs that solve the same problems more effectively. So the last bit of my talk is going to show some ClojureScript. You don't have to know ClojureScript. It's not important. All I want to demonstrate are some features of ClojureScript that I now consider essential, that in fact are missing from JavaScript without me doing a bunch of like boilerplate work that I don't think is interesting. I'd rather just use a thing that solves that problem for me so I can just focus on my problem domain. So there's three key things that I'd like to talk about. The REPL, equality, and specification. I suspect there'll be a lot of talks about TypeScript, and the previous talk was also about TypeScript. Again, TypeScript, ES6, all this stuff is cool. I want to show you simply a different way of thinking about the same types of problems you might want to solve, but with different set of tools. So the first thing is the REPL. So you all are familiar with the node REPL. You fire off node, you use it. You get to check a couple things. But the thing is that that's very different from how a Lisp programmer or, say, a Smalltalk programmer thinks about this. Like, if you've ever seen Dan Ingalls talk about Smalltalk, you should run and see that if you haven't seen that yet. And the idea there was that the programming system should be alive. It's a living thing. Like, it's not just I load a REPL and I test a thing, but really the REPL is a whole interactive environment that's just on all the time. So here in the background, I have, sorry, one second. Here in the background, I have the browser open here, Chrome. I have Chrome open, and it's on this page, and I can type in an expression here, and I'm in IntelliJ. Oh, but let's start this again. Sorry. Sorry, one second. So here I have Chrome, and then let's see if this works. Yes. So what's interesting here is that, you start Node, but I have the same thing that you would have in Node, except I have it in my editor, right? I'm in my actual development environment, and I have a REPL, and I can, for example, load this file, right? And all of this has been evaluated. I've loaded. Oh, you don't see anything. Sorry. Somebody should have said something. Let's fix this. Displays. Arrangement. Mirrored. Sorry about that. OK, that's better. All right. Let me speed this up and let me just repeat what I just said. So here I have Chrome. It's open. Here I'm in IntelliJ. In my source code editor, I have a REPL here. I've loaded this file. I can run expressions. And what's happening is that this REPL has a connection to Chrome, and it's compiling the JavaScript on the fly, and it's evaluating and returning it here so that I can work from this text editor. So I can put my cursor here. I can switch into this library, and I can evaluate these expressions. Right? So my first demo here is equality for all, where I show that I want equality to make sense in the sense that in JavaScript, this was something you can't fix. Equality was set so long ago, there's no fixing it without breaking the internet. In ClojureScript, this is something that in Clojure, equality was just done right from the beginning. So there's no coercions. Equality is not coercive. 1 is never going to be the blank string. I don't have to use a special equality operator. 0 is never going to be equal to false, right? No coercion. But more importantly, I can take compound values, right? I can take 2 vectors, and these are exactly the same as JavaScript arrays, but they're immutable. And I can say, are these the same? I don't need to go find a third-party library to check 2 values, right? So if you've written any non-trivial UI program, you're like, is this domain entity the same as the domain entity that I currently have, right? And you have to go find something. Or you're writing tests. This is very common in tests, even more so than inside of your program. Is the value that gets returned the same as my example value? And the fact that I don't have to do anything, it's just a fundamental feature of the language, is great. Down here, I have a map. It has a foo and blah, 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 so I can do the same thing for maps. That's not that interesting. But down here, I can do complex keys. So in JavaScript, with JavaScript objects, you can only have string-based keys, and that really limits how you can use the object inside of an algorithm, right? So a lot of times people say, in order to write a good algorithm, use the right data structure, right? So because I can embed complex keys, I can often shape the map so that it fits the algorithm that I'm writing. I don't have to go through some convoluted thing. So here I can say, find the item that has the key, which is a vector with 1 and 2, and it gives me the value that I expect. You may think that this works with ES6 maps, but this is not true. If you've ever tried to use ES6 maps, it's, in my opinion, completely broken. So here I'm going to make an ES6 map, and I'm going to go get, this is a JavaScript array. This is not a vector. The JS says make a JavaScript array. And I made this map, and I say, give me the value that has the JavaScript array 1, 2, and I get back nothing because ES6 maps only do lookup by reference. Right? I cannot use ES6 map in algorithms out of the box. I can't use it in an interesting way. And to me, the fact that this was even shipped this is definitely one of those cases where I have a lot of criticism because even you can do this in Java, you can do this in Objective-C, but ES6 maps and sets, because the same implementation really, they're broken. I have to pass the original array to get the thing that I want. Okay, so let's. We talked about that, and I want to move quickly to specification. So this is going to be interesting for people who do TypeScript or are interested in TypeScript. So what does ClojureScript offer for specification, right? It's a dynamic programming language. We don't do compile time checking. You can use this for compile time checking, and people have done it. That's not its main purpose. You can use it for that. But I want to demonstrate things that are impossible to do, or nearly impossible, with a traditional compile time check type system. So here I'm going to make a specification for this thing called first name. It has to be a string and last name. These are going to be keys inside of a map. In TypeScript, that would be like interface person, first name, last name. Cool. They have to be strings. This is semantically the same thing. A person is a map, a ClojureScript map that has these two keys, first name, last name. Then I go, is this map with just Bob a valid person? It better be no, because there's no last name. Down here, I say, explain to me why that's not a valid person, and it tells me a person needs to have a last name, right? So I have a very succinct way for taking some data. I might have written this data a year ago, but I have a specification mechanism that lets me now talk about what that stuff should look like. Very similar to TypeScript, this idea of doing something gradually. You wrote a program, now you want some more clarity about the meaning of the program. You can do this. So down here, I go, is this valid? And it's true. I'm going to add a new thing called school, and then, okay, nice. And then, what's a teacher? We can reuse specs. So you can't do this in TypeScript. You can't just make a bunch of interfaces and say, this interface is not, I mean, inheritance, we really want to talk about inheritance. I don't really care about the inheritance relationship. I just want to reuse an existing set of specifications and add one new piece of information. Like, there's no real way to do this with TypeScript. If you know about it, please tell me. I looked around at the documentation, but I couldn't see a way to do this. So here I say, a teacher is a person who also has a school. This person is not a teacher because they only have first and last name. But this one is, right? Because there's a school. So to take it one step further, you know, types are great because they really serve two purposes. One purpose is for the computer. The computer checks that all your types match. Okay, that's cool. And the person gets that back. But really, to me, the most valuable thing about types are their function as a specification. That when I look at somebody's code, without compiling the code, without running it or doing anything, the types tell me something about what the original author intended. It's a form of documentation. I actually think that is far more important than the compile time type checking. I don't think it's not important, but I think the documentation part is the most important because, again, programming is a social activity. How do we communicate with other programmers? So down here, I'm showing you that we can take our specs and we can annotate them. So not only can I tell somebody, this is what I meant, you can take my spec and you can make examples from it. Right? This is something you can't do with TypeScript or in most type systems. So here I go, okay, first name, last name, and school. And for each of these, I now provide a set of example values. Down here, I can say, generate me a first name, generate me a person, right? And generate me a teacher. Like, that's amazing, right? I can jump to anybody's code. If they gave me a spec and they took the time to document what the examples should look like, I can generate the example, right? So many times when I look at an API, it's a convoluted domain object, and I have to go find a test, copy and paste the thing to figure out what does the thing actually look like. The types don't tell me enough, right? And it's very tedious. Here, we're really adding a next level of documentation to the specification that we're making. So just to wrap it up, I know I'm running out of time. So here I have a function that takes a teacher and extracts the school. Okay, whatever. So here I'm saying, I want to specify that this has to be teacher. Notice that the function itself isn't annotated in any sort of way, but I'm able to provide a spec after the fact. And people often want to munge the types and the specification together. And I think when you separate them, there's a lot of power. For example, this spec actually can be used from Clojure or ClojureScript. We can use the specs anywhere, right? It doesn't matter which platform we're targeting. And by keeping them separate, that's actually very valuable, because it may be the case that the platform implementations are different. So here I'm going to instrument this function saying I want this to be checked. Here I can say generate a person, and I want to call that function, and it's going to fail because teacher to school expects a teacher, not a person. And if I run the second one, it's going to work because that person has a school. And finally, this test is a broken test, right? You would think, oh, it's not compile time checking, but with instrumentation, you have to write tests anyway. I don't care how many types you have, right? For your domain business logic, you're going to have to write tests anyway. So instrumentation gives us this ability when we run the tests, we can get this feeling of interactive checking, because here it says teacher to school. Down here, this doesn't conform to the spec because it doesn't contain a school. So let me fix my test. School, bar high, right? I redefine the test, I rerun the test. Boom. And notice I never left my text editor. Like this idea of I run a REPL only to test snippets, it's just not how I work. What you just saw is exactly how I actually program. It's actually when I sit down to work, everything that you saw me do is how I sit down and solve problems. And hopefully, again, this is not use Clojure or use ClojureScript. It's compare my approach to solving problems to the set of tools that you have for solving problems. And maybe, I mean, ideally, this could influence the way that, hopefully I'm wrong, that JavaScript has a lot more to learn, has a lot more to grow. Some of these things can happen through TC39. Perhaps some of the things I'm demonstrating are just you writing a library saying, that's a great idea. We should embrace that. Again, just some controversial statements. Like I've been doing functional programming for a long time now for all types of work, UI work, backend work, systems, doesn't really matter. But I haven't used classes or inheritance in years, data, all the things. I think this is really important. You should try this in JavaScript. Don't use that stuff. No unmanaged state. So you use mutation. So if you like Redux, why is Redux the only place where you use managed state transitions? What happens if you use managed state transitions everywhere, all the time? Does your program become easier to reason about? And finally, generality of specifications versus compile time checking only of types. This is not anti-compile checking of types. I'm not anti that. But hopefully I demonstrated some things that I know you must know that it's very difficult to do with traditional type systems. That's it. I went over. Sorry. But thank you.